GATE 2017 Metallurgical Engineering Question 11. For a FCC metal, the radius of largest sphere that can fit in the tetrahedral void in nanometer is, it is given that the lattice parameter is 0.401 nanometers. So let us look at the FCC lattice. Now here you can see there are two types of voids that are possible in FCC lattice. One is the tetrahedral and the other is octahedral void. So we need to determine what is the radius of largest sphere that can fit into this tetrahedral void. Fine. So that is our objective. Now if you look at this image, now the atoms are arranged in FCC closed pack structure in this form, where B is one layer of atoms, then the next layer of atoms sits in the voids of layer B of atoms, okay, and they form a tetrahedral void. So here you can see, so this is a regular tetrahedron. In regular tetrahedron, all the edge lengths are equal. All the edge lengths mean all the three edges of the base triangle and the side edges, they all will be equal to PR, equal to PQ, equal to PS. All these edges are going to be equal, and since in this image you can see the length of this edge is equivalent to 2 times the radius of atom, okay, and so they all will be equal to 2 times radius. Now let us look at the base triangle first. This is the base triangle here. This is the top view of the tetrahedron. The top view of the tetrahedron looks like this, where this is R, Q, S. Fine. And all the three sides are equal. This is the centroid. Okay. Let us call it as C, centroid C. The point C divides the line. This is point U. Here is U. Divides the line RU in 2:1. Okay, that is RC ratio CU is 2:1. Okay, now we need to determine the length of RC. Okay, so what is the length of RC? How will you determine? By determining the total length, that is RU. So if you take this as a triangle, from triangle RUS, applying Pythagoras theorem, that is RS square will be equal to RU square plus US square. Now what is RS? RS is 2 times R square will be, what is RU? That you need to determine. US is R square. So from this equation, the RU square is nothing but 3R square, or RU is root 3R. We are interested in RC. RC is nothing but 2 by 3 of RU, that is 2 by 3 into root 3R, 2 by root 3R. Okay. Now I am interested in finding what is the vertical height of this length PT. Okay, this side. Fine. So in order to determine the length of PT, I am going to consider this right angle triangle. Okay, highlighted in green. Fine. And what is this point? This point is C. C is the centroid of the base triangle. So from this right angle triangle, from triangle PCR, okay, if I apply the Pythagoras theorem, I will get PR is the hypotenuse, PR square shall be equal to PC square plus RC square. Fine. So what is the value of PR? PR is nothing but 2 times the radius, shall be equal to PC square plus RC square. What is the value of RC? The RC we determined it to be 2 by root 3R. Okay, it's square. Fine. So upon solving this equation, you will get the value of PC as 2 by root 2 by root 3 R. Fine. Now I need to determine the centroid of the overall tetrahedron. Now, where is the centroid of overall tetrahedron? It will lie on this vertical line PC, such that, let us say, this point represents the centroid of the overall tetrahedron, and let us say it is identified by letter B. Okay. So centroid of overall tetrahedron, that is B, it is such that PB ratio BC is nothing but 3:1. Okay. Therefore, the PB will be nothing but 3 by 4 of PC. And what is PC? It is nothing but 2 root 2 by root 3 R. Okay. Here we have determined the value of PC. Okay. Upon simplifying this, we will get the value of PB as root 3 by root 2. Now let us assume, now we know that there is one atom sitting at point P. Okay. Another atom is sitting at point Q, R, S, and the largest sphere that can fit into this tetrahedral void will be sitting at point B. Okay. So let us say this is the sphere that is sitting at point B. Okay. It will fill up this vacancy, tetrahedral void. So it means that PB is nothing but the sum of the radius of the atom plus the void atom. Okay. Let us say it is RV, small rv. Okay. That is what we need to determine. Okay. The radius of largest sphere. This is the radius of largest sphere. Okay. That can fit into this tetrahedral void. And mathematically, they both should be equal to PB. And PB is nothing but root 3 by root 2 R. Okay. So from this equation, upon solving this, it will be root 3 by root 2 minus 1 R, and it is approximately 0.225 R. 0.225 times R. But in the problem, the value of R is not given to us. It is the lattice parameter is given to us. So what is the lattice parameter? So what is the lattice parameter? Here is the lattice parameter. Let us say it is A. A represents lattice parameter, and this is the radius R of the atom. Fine. So this is the ball model of an FCC atom. Understood? So we can easily determine the relation between A and R. Let us say if you take this as a triangle, you join this as a face diagonal. Okay. If you take this triangle, so what is the length of the hypotenuse? Because this is 90 degree. So the length of this hypotenuse will be, this will be 2R plus R plus R. It will be 4 times R. Okay. And these two sides are A. So from this triangle, applying Pythagoras theorem, you will get 4R square will be nothing but A square plus A square. Okay. Or 16R square will be equal to 2A square. You can further simplify this. 2 will be taken care of by this 8R square, or R is nothing but A by root 8 or A by 2 root 2. Now the largest sphere that can fit into the tetrahedral void is about 0.225 times of R, or 0.225 times of A upon 2 root 2. You can write it in this way. You can further solve this problem. 0.225. What is the value of A given to us? It is 0.401 nanometer upon 2 root, and upon solving you will get the result as 0.0318 nanometer. So this is the radius of the sphere that will fit into the tetrahedral void, whose lattice dimension is 0.401 nanometer. Now, to know more about the concept of tetrahedral and octahedral voids, kindly refer lecture number 21, Introduction to Materials Science and Engineering by Professor Rajesh Prasad, Department of Materials Science and Engineering, IIT, Delhi. Thank you.